Here we have moles this time. And instead of going from 2 moles, we're going from moles. So we're going to multiply by a fraction. We put moles on the bottom. And on the top, you put atoms. In 1 mole, you have 6.02 times 10 to the 23 atoms. So when you multiply across, you should get 1.9685 times 10 to the 24. That is not a complete answer because it's missing units. So we should have atoms as our unit because moles cancel. We're left with atoms. And then you need to have the proper number of significant figures. So here we have 1, 2, 3 significant figures. So we need to have 1, 2, 3 again. So our answer is going to be 1.97 times 10 to the 24 atoms. If, for some reason, you got a really large number, if you ever get a number, something like 1.96 times 10 to the 49th atoms, to put this into perspective, that's more atoms, they think, than there are in the entire universe. Okay, that's how large that number is. Right? If you think about it, it's 25 times larger than this number. It's a big number. Okay? So anytime you get 40, something in the 40s, you made a mistake. You need to have something in the 20s. Right? I'm trying to develop the idea of scale to you guys, like number sense, I guess. Okay. Questions? We just need more practice?
Yes.
Yeah.
I don't want to do the other practice problems on this page. Turn to page 13. We're going to do questions 1, 2, and 3 on page 13. The answers are in parentheses, but the first 2, the significant figures are off. So let's look at the first problem. You see the answer in parentheses there?
Yeah.
Would you change that to 1.90 times 10 to the 20, what is it? 22nd atoms? So it's 1.90 times 10 to the 22nd atoms. And the answer for sample problem number 2 should be 130 moles, not 129. 130 moles, not 129. All right, you guys have the last 10 minutes of class to work through these 3 practice problems. Your answers are there for you. I'll go through them the last probably 4 minutes really quickly so you guys can kind of see them worked through. All right? Practice, go.
Okay.